And in this module, we are going to look at the two categories of types that you can create in C#, reference types and value types. Understanding how these types behave is important to writing software that works correctly. We're going to see how we can pass values and references between methods in this module, so you will have a firm grasp on how parameters behave too. We're going to do this by writing and exploring with our unit test project, so prepare yourself for writing some tests. The topics in this module are topics that, if you keep programming in C#, you'll eventually become so comfortable with these topics they'll become second nature. Since you're just beginning, we're going to spend the entire module focused on the difference between values and references in C#, because I've been using terms like object reference and return a value, and now we get to see what those terms really mean. So let's use the following two examples. First, let's talk about a piece of code that creates a new variable B and assigns to be a reference to a new book object. So anytime you are working with a class, anytime you write a class, or anytime you use a class provided by .NET or some other NuGet package, you are using what is known as a reference type. And what I want to do is explore how reference types work in memory. So imagine this big purple box as representing all the memory that is available on your computer. So first, that line of code would force the .NET runtime to create a space in memory for the variable B, because we need memory to store values that are inside of variables. And by the time that statement finishes executing, there will be a value in the letter B. This value might be something like the value 1072, because this value really represents a memory location. So somewhere in the megabytes and probably gigabytes of memory on your computer, there will be memory cells where the .NET runtime allocates space for this new book object that you want to create. And this value 1072 inside the variable is the address or the location of where the book is in those gigabytes of memory that are available. So we talk about the variable B really being a reference or a pointer to where the book lives on your computer. The variable doesn't contain the book, just like an email that I write to someone else doesn't contain that other person, but I can use an email address to reference the other person and deliver mail to them. So later in the code, when I do something like b.addGrade, the .NET runtime can follow the reference in my B variable to find the right book. And that might be one of 10,000 books that you've created in memory. But I can find the right book given the address. And from that book, the .NET runtime can also find the name of the book and the grades that are associated with that specific object, because those are the fields or the state that is a part of each book. And those fields are actually references themselves, so references that would point to other locations in memory. And now let's compare this to another line of code, which is x equals 3. 3 is an integer, and integers are special types in .NET. Integers are what we call value types in .NET. And here's why. For a value type, the runtime still creates space for my variable x, but now instead of storing a reference inside of the variable, I store the value itself. So there is no pointer to an integer that's somewhere else in memory in this variable. There is simply the value of the integer, and it's stored directly in that variable. Now there's many simple types in .NET that are value types, and they behave this way. So integers and floats and doubles, those are all numbers, and they all are value types. I'll show you how you can create your own value types, and also show you how to tell if you are working with a value type or a reference type later in this module. But for now, let's just focus on the difference between a variable that holds a reference and a variable that holds a value. B holds a reference because it's typed as a book, and book is a reference type. X holds a value because it's typed as an integer, and int is a value type. And one points to another location or references an object, and the other one holds a value itself. If this doesn't sink in right away, don't worry, it can take some time, and we are going to spend some more time on this topic by writing some tests. Before we get to work in this module, there's something I want to do to make the work easier, because what we're going to start doing is making changes inside of the gradebook project and also inside of the gradebook.test project. And that means I'm going to need to build both of these projects and run tests in the test project. And I don't want to go to the command line and keep switching directories to build the different projects. I just want to be able to go to one location and say, build everything and test everything you can find. And the way I can do that is by adding a solution file. A solution file is something that tools like Visual Studio understand, and also tools like the .NET CLI understand. And what a solution file is, it's really just a file that keeps track of multiple projects. So if I add all of my projects to a single solution file, I can open that solution file using a tool like Visual Studio, and all my projects are loaded in for editing. Or from the command line, I can use a tool like the .NET CLI to say, please do a .NET build, and it will build all the projects it finds in the solution. Or I can say .NET test, and it will find all the projects that are unit testing projects in that solution and run my unit tests. And creating a solution file is very simple. Let's go out to the command line. I am in the top level folder for my collection of projects, the gradebook folder. This is the folder where the source and test folders exist. And what I want to use is the .NET New command, and I want to point out that one of the templates available with .NET New is the template that will create a solution file. So solution files have the extension .sln. So the shortcut name for this is .NET New, and then just specify sln for solution file. That will place into this folder a file that has the same name as my directory, so I have gradebook.sln. That's the solution file. Now what I want to do is add projects into that solution file. I can also do that with .NET, and it's very easy. I went to .NET sln add, so these are operations associated with the solution file. .NET sln add, and let's go into the source folder and go into the gradebook folder and find gradebook.csproj. I want to add that project to the solution. And then I went to .NET sln add in the test folder. Let's go to the tests folder and find the csproj file there. That is now part of my solution. And now what I could do if I'm using a tool like Visual Studio is just open the solution file. But I can also do things like .NET build. And what .NET build will do is look for a solution file in the current directory. We've seen previously in the course where .NET build will look for csproj files, but now it will find the solution file and say, oh, you must want to restore and build both gradebook.csproj and gradebooktests.csproj. And now I can come to a single location just to do a .NET build and also a .NET test, and all of my projects will build and all of the unit tests across all of my projects will be found and executed. So this is going to make our work much easier as we move forward. For our first set of tests in this module, I want to focus on this scenario where we have a method that constructs a new instance of a class, so a new object, a new reference type, and then returns that reference to the caller. Some of the questions you might have about this scenario include, does this method always return different objects, or does this method always return the same object? Those are valid questions, and I would encourage you to keep a unit testing project around that you use purely to answer those types of questions and experiment. It's a good way to gain experience not only with the C# language, but also to understand how .NET behaves. And I would even check that project, that experimenting project, into a place like GitHub, so you can keep it around and take it with you, and you could have it as a private repository, but you'll never lose this code that you're writing and building on to explore the language and the framework. Now my goal is that we're going to write a test that instantiates the book class a couple different ways, and then tries to keep track of book objects using the book name. Right now, this name is private, so I only have access to the name when I'm inside of the book. I'm going to change this, and later in the course, I will show you a better approach to do this. But for right now, I'm just going to make this field public. So I will be able to access name from code outside of the book class. And I'm also going to change name to be uppercase N name. So the convention in C# and .NET is that when you have a public member, whether it's a method or a field or some of the other member types that we'll look at later in this course, that public member always has an uppercase name. So this will be uppercase name, and that means I need to make a change in the constructor because C# is a case-sensitive language, so it no longer sees lowercase n name. It no longer sees that field. There's only the uppercase field. And now I can also get rid of the this keyword because now the C# compiler can differentiate between name, the field, with an uppercase N, and name, the parameter, with a lowercase n. So those are all the changes I need to make to book.cs. I'm going to save that file and close it. And now what I want to do is write some new tests. Now these new tests are not centered around the book, so I want to put them in a new class and in a new file. And I also want to rename this particular test. The name currently is test1, and that is a name that I always like to get rid of because it gives no indication as to what's actually happening inside. When you're writing your test classes and your test methods, it's important to name them properly. It's just as important as the other classes that you write for your regular code. And typically what you want to do with a unit test is make some statement of fact about your software. That's why we have this fact attribute, and that's why XUnit chose the word fact to identify tests. We're trying to prove a fact about how our software behaves. So I could say that the book calculates an average grade, or I could say that it calculates stats, statistics. But this name, book calculates an average grade, is far better than unit test 1, so we'll stick with that. And now what I want to do, because I want a new class that has tests inside of it, I also want a new file. I'm going to use booktest.cs as a starting point, and I'm going to make a copy of this file to get started with my new class. So right-click on the file and say that I want to copy the file, go to the folder gradebook.test and right-click on that and say that I want to paste the file. If your new file doesn't show up, you can always hit the refresh button here in the Explorer, but I can see booktest1.cs or booktest.1.cs. I want to rename this. What we're going to do are some type tests. So how do reference types behave? How do value types behave? I'll call this type test, and that means at the start of this file, the class name will be type test. And then inside, I can start thinking about the first test that I want to write. For right now, yeah, sure, I can just call it test 1. I have no problem with that when I'm just starting to write the test. But once I figure out what it is I'm really testing, then I'll want to rename this method. So what I really want to do inside of this test, and again, just to explore a little bit, I'm thinking I want to invoke a method that will instantiate a book. And then I want to write some sort of test that can prove or disprove that every book that is returned from that method is the same object or it's a different object. So let's create one variable named book1 and invoke a method named getBook. And let's imagine that we can provide every book a name. A book has that capability. So let's call this book book1. And then I want to do the same thing, but with a different variable, book2. Before I get that far though, let's create this method getBook. One way to do that is to place the cursor on the method and press Control period. I've shown you this tip before. This will generate that method for me. Notice this is a private method, and that's fine. Remember, you can also leave the private keyword off, and that's the default for a member. By default, a member is private. I do not want to place a fact attribute on this method because this is not a unit test in itself. It's just another method that I call from a unit test somewhere else. Right now, the return type of this method is object. Object is the lowest base type in the .NET framework. We'll talk about that later in the course. But what I really want to return from here is a book. So I'm going to change the return type to book. So remember this identifier to the left of the method name here. This is describing the return type. Void would be a way of saying this method doesn't return anything, but we do want to return a book. We're passing in a string parameter that is really supposed to be the name of the book, so I'm going to change that from V over to name. So again, all the names should make sense. And now I'll write a very simple expression. What I want to do is return what happens when I use the new keyword to construct a new instance of the book class, and I pass along that name parameter. So that's a simple implementation for this method. And now, if I have the variable book1, and then I declare another variable after I copy and paste that line, but we'll call this variable book2, and I give this book a different name. The question I have for you, and the challenge for you, is to write an assert statement where you assert that something is equal to book1.name and something is equal to book2.name. So if you believe this method always returns the same object, then perhaps both of these books will have the same name. Perhaps they are both going to be book2 because that's the last time that we invoked getBook and that's the name that we passed in. Otherwise, if you believe this method is returning different objects, then you might put the expected value in here as book1 and book2. So pause the video, make this test pass by putting in the correct expected values, and then we'll come back and review the correct answers in the next clip. So back at the command line, I can be in my root folder, the gradebook folder, and from here I can run .NET test. .NET test will find the solution file that we created, look at all the projects inside, find the unit testing project, and run all the tests inside. And you can see I have now 2 passing tests, and that's because back in the editor, what you should have found is that every time I invoke getBook, I'm creating a new and unique and distinct object in memory. So the first book can have the name book1, and the second object can have a different name. So different pieces of state in those 2 different objects. And that's why I renamed this method as getBook returns different objects. So you always want to give a real meaning, a real name to your unit testing methods. And this is stating a fact about how the method getBook behaves. So here's another question you might have. Can two different variables reference the same object somehow? Let's try to figure that out. What I can do is make a copy of this test. I'm going to paste it down here. I'm going to line things up and I'm going to change the name. So I want to say that two variables can reference same object. How can I do this test? Well, let's keep the code that says book1 equals getBook with the name of book1. But now let's just say that we want to declare another variable, book2, and set it equal to whatever value is inside of book1. Remember, variables hold values. They always hold values. It's just that those values can be references or can be pointers to an object that is out there in the memory of my computer. So the variable book2 is always going to contain a value. It's just what is that value that goes into book2? Is it a reference that points to a different book? Because does this line of code somehow copy the existing book object that we've created in memory? Or do we simply take the reference or the pointer that is the value inside of book1 and copy it into book2? How can we check this? Well, one way to check it would be to assert that both the variables point to an object that has the name book1. But let me show you another way. What I can do is I can use some other asserts. So there is an assert that XUnit provides called same, where I can assert that book1 and book2 point to the exact same instance. So verifies that two objects are the same instance. So both of these references would be pointing to the same object in memory. That's like up here, I could say that I want to assert that book1 and book2 are not the same. So we know that these are two different objects because they contain two different names. But we want to test if assert.same is true, and then I want you to write one additional assert. Assert.same is really behind the scenes doing something similar to this. It's asserting that object.referenceEquals is true. So first of all, reference equals is a method, a static method that is available on a class named object in the .NET framework. When we talk about inheritance later in the course, we're going to find out that everything in .NET derives from this object base class. But reference equals, you can pass in two parameters like book1 and book2, and reference equals will tell you if these are the exact same references. So are the values inside of these variables pointing to the same object? If so, reference equals would return true, and this assertion will work. A nicer way to do this with XUnit, though, is to use assert.same. Now if I come back to the command prompt and clear the screen and run .NET Test again, we should be able to find that that test, our third test, is also successful. So now we know that yes, two variables can reference the same object. They can reference different objects, but because variables always hold a value, they don't hold the objects. They can hold values so that both of them can point to the same book. So in this clip, I want to give you a new challenge, but before I give you that challenge, I want to make sure that you understand the implications of this line of code right here. So when I say book2 equals book1, I'm not making a copy of some book object and placing that into the book2 variable. Instead, what this line of code will do is take the value that is inside of book1, that value is a pointer, it's a reference, and we're going to copy that value into the book2 variable. So we will have the same pointer value, where a pointer is just some number that's going to lead us to some memory cell that's in our computer. So keep that in mind as I write our next test. What I want to do is write something that will check to see if we can change the name of a book and how that happens. So I'm going to make a copy of the test that we already had, which is getBook returns different objects. But I'm going to change things around a little bit. First of all, I have to change the name of this test. Let's just call it test1 for now until we, again, figure out what we're doing. Let's just create a single book, and we'll start that book off with the name of book1. But now I want to invoke a method called setName, and I want to pass in that book as a parameter to the method setName. And I want to pass along a different string, which will be the new name for this book. So let's call this new name. Now, before I set you off for your challenge, let's create this method. So again, I can use control period and generate this method. That will generate the method right here. Being a private void method is okay. We are going to take a book and we are going to take a name. And then all I want to do is say this book's name field should be equal to this incoming name parameter. Now, the challenge for you, again, is to write an assertion that works. So I want you to write an assert.equal on book1.name. And the question is, what will this calling unit test method see? Will it see the value book1, which is the original name that we gave to the book, or will it see this new name? So keep in mind what will happen here. Put in the value that you think we'll see, and then come back for the next clip to see the answer. As you should have discovered, I do have the ability to change the name of an existing book object by invoking a method and setting the name field on a book object. So I'm invoking a method, I'm passing along a reference to book1 as well as a new string, the new name, and I can then assert that this book object referenced by book1 does have that name. So I named this test canSetName from reference because what I'm passing to this method is a reference, but I want to be very clear about the terminology here. In the C# language, when you pass a parameter to a method, you are always 100% of the time passing a parameter by value. So perhaps you've heard of these terms, pass by reference versus pass by value. Perhaps you've heard them in other programming languages because it describes how a parameter is given to some method that you're invoking. And in C#, the answer always, 100% of the time, unless there's another keyword involved, the answer is always you're passing by value. And what that means is that I'm taking the value inside of book1 and I'm copying that value and placing it into this parameter book. It's a lot like saying book2 equals book1. I'm taking the value inside of the book1 variable and placing it inside of this variable. In this method call, I'm taking the value that is inside of book1 and I'm placing it into this parameter book. So it's a copy of that value. It just so happens that that value represents a pointer to a memory location. So it's a reference to a book object. And that would be very different if I was in an environment where this language and this runtime would pass parameters by reference, because then this book parameter would receive a reference to my variable book1. And then yes, this parameter could still make changes to the object, to that book object, because my parameter holds a reference to a variable that still holds a reference to my book object. But in a pass by reference scenario, I can even make changes to that book1 variable itself from the other method. And that's something that cannot happen if I use pass by value. So let me give you another test, another scenario to evaluate. What I'm going to do is make a copy of both this unit test, canSetName from reference, and this method setName. I'm going to make a copy with Control-C of both of those, and I'm going to, up here, paste them in, and we're going to change them around a little bit. So first of all, let's call setName something different. I'm going to say that this is setName. I'm going to say the new name of this method is getBookSetName, because I want to do two things. I want to say that book equals a new book with the incoming name parameter. And then we don't really need the second line of code. What we're doing when I say new book and passing in a name is we are constructing a new book instance and we're setting the name by passing that name into the constructor. And now, so we don't conflict with the other method name, I want to change this to be, for now, just test1. And now I'm going to leave it up to you. I want you to put in the value that you expect to see here for assert.equal, and then run the test and see if you got things right. But of course, we're also going to have to invoke this method, getBook and setName. And I just want to remind you about what's happening behind the scenes. Book1, the value that is inside of this variable is now a reference to an object that was just created by the method getBook. And now when I invoke getBookSetName, what is being passed along as a parameter is a copy of that value. So let's just say, to make this a little more concrete, that the value inside of book1 is the value 10. So our book was created in memory location 10. What we're doing is taking that 10, copying it into this parameter. And now the question for you is, when I say that book equals a new book, am I writing that value into the book1 variable? Is there a way for this method to reach out and touch my book1 variable? Or am I just making changes to this local parameter? If you think you're just making changes to the local parameter, then the assert here should be an assert that book1 is the expected value. But place in the value that you expect to find, run your test, and see if you're correct. We'll come right back and explain the answer. As you probably discovered, this new test that we wrote, which I named C# as pass by value, in this test, the name of the book at this point is still book1. Because again, what we did was when we invoked getBookSetName, we made a copy of the value that is inside of this variable book1, and we placed that copy in this parameter. So this line of code is constructing a new book object, and we're storing a reference to that object in this book variable, which is a parameter to this method. But this parameter is different from the variable location that is up here in this method. Those are going to be two different memory locations. We're storing that value into a new different memory location. So this variable book1, the reference that it holds is not going to change when we call this method. And that's exactly what the designers of the C# language wanted. When you pass a variable to another method, you don't want that other method to unexpectedly change the value or the reference that is inside of your variable. That would be an unexpected side effect of invoking that method. And just for fun, I even added the line of code here that says, look, book.name equals name. I'm going to try to force the name into the object that we created up here. But again, since we have created a new book object and placed a new reference value into this parameter, this is not working with the same book object that we worked with up here with book1. Now, if this is something that I want to do, if I want to be able to make changes to the variable that is passed to this method, then I can change this method so that the parameter is passed by reference instead of by value. So remember, the default is always, always, always to pass by value, but I'm going to copy C# as pass by value and getBookSetName. I'm going to copy and paste those two methods again so we can change them around. This method I'm going to call C# can pass by reference, or let's just call it pass by ref. And then on the method getBookSetName, I'm going to add a new keyword in front of the first parameter, which is the ref keyword. And that tells the C# compiler that when this parameter arrives, or whoever calls this method, this first parameter will be passed by reference and not by value. By reference means what I will receive is not a copy of the value that is in a variable that I pass along. Instead, what I will get is a reference to the memory location of where that variable is stored. And because this method now has a reference to this variable, to that memory location, I can now, from inside of getBookSetName, I can now make changes to the value that is inside of the book1 variable. Now, in order for this to work, and in order for me to invoke the proper method here, getBookSetName, I also have to use the ref keyword here. The C# designers wanted to be sure that whoever is calling a method that is using pass by reference will be aware that they are passing a variable by reference, and that means the variable could be changed. So now remember, the only real changes I've made here are that I've added the ref keyword to my first parameter, and I've added the ref keyword here where I am invoking the method getBookSetName. And now the question is, will I see book1 here, or will I see new name? Why don't you pause the video and give it a try, place in the value that you expect to find, and then come right back. So what you should have discovered is that, yes, this book1 variable, after we invoke this method and pass book1 by ref, the book1 variable is now pointing to a different object, and this object does have the name new name. So that's how we can pass by ref. I will say that in day-to-day programming, you do not pass parameters by reference that often, so you won't see or use this ref keyword very often. There are some APIs that demand it. But I will point out that there is an alternative to ref, which is the out keyword. The out keyword also does a pass by reference, so this test will still pass. It will still behave the same. The only difference between ref and out is that with an out parameter, the C# compiler assumes that the incoming reference has not been initialized, and so it will be an error if you do not assign to an out parameter, because you are expected to assign something to this output parameter now. And you can see my compiler error is that the out parameter book must be assigned to before control leaves the current method. This is like leaving an uninitialized variable around. So that's the difference between ref and out. This code, if I were to comment out that line of code and change this back to a ref, that would be legal. But with the out keyword there, I am forced to initialize the output parameter. We've spent most of this module talking about reference types because we've been working with a book, and a book is a reference type. I'll explain why in just a bit. But let's also look at value types. So let me write a test that we will start off with the name just test1 again. But I want to say that variable x equals what happens when I invoke a method called getAnInteger. So IntelliSense was a little too helpful there. I just want to invoke a method getInt. Let's create that method with control period. I'm going to change the return type here from object to int. And what I can do is simply return a 3. So now it's up to you to write an assert.equal. What do you think the value of x will be? Well, hopefully you will say, and will have tried, that 3 is the expected value of x, and that would be true. It's pretty obvious what's happening here. I'm returning a 3, so the 3 has to go into x. In many ways, value types are easier to reason about. Whenever you're working with integers and floating point numbers and even date times and booleans in C# are what we call value types, then what you see is what you get. When I return a value, the value of 3, then I'm taking this 3, which is produced by the method, and copying it into the memory location, which is reserved for this variable x. So x holds a value, and that value is 3. Previously, I could also say that something like book1 holds a value, but in fact that value is a reference to some object that is somewhere else in memory. When we talk about value types like integers and booleans and floating point numbers, the value is what you get. And now what I want you to try is creating a method called setInteger, where you pass x along and try to do something to x. So I'm going to use control period to say, yes, generate a method for me called setInt. And inside of this method, let's just say x equals 42. So now I want you to try to adjust the test to match what you expect to be in the variable x. Is it going to be a 3 or is it going to be a 42 because of the assignment that we made inside of this method? What you should have discovered is that you still see the value 3 inside of the variable x. And again, that's because C# always uses pass by value when you invoke a method. So when I invoke the method setInt and pass along x, the value 3 is copied from the x variable into this variable that is a parameter to setInt. And this variable could be named anything, by the way. The parameter names don't have to match the variable names that you use to pass into them. But the result is going to be the same because when I say z equals 42, I'm copying 42 into the memory location for this parameter, the parameter z, and that's the only place where I can see that value now. The original variable x is unaffected. What I want you to do is pause the videos and try to make this test pass by changing the setInt method to pass by reference. You can try that now. So if I want to see the value 42 inside of x, I will have to pass by reference into this method. That gives this method a reference to my variable named x. And because this is passed by reference, I'm also going to have to use the ref keyword here. Again, the C# language wants to make it very explicit when you are not doing the default thing, which is to pass by value. So I'm passing x by reference. I know that this method can now change my x variable, and indeed, I should be able to run the test now and see that the value inside of here is 42. That would be correct. I told you at the beginning of the module that I would tell you how to differentiate between a reference type and a value type. How do you know when you're working with something that behaves like the integer, a simple value type? And how do you know and can be sure that you're working with a reference type, so a type like the book class that we wrote? Well, the rules are very, very simple. Whenever you are working with something that has been defined by a class, then you are working with a reference type. So if I wrote a new type here inside of this file, a new type that I'm going to delete here in just a few seconds, so you don't have to follow along with this part. But if I create a new class, let's just create a class called person, then I am defining a reference type. Any variable that is typed as person, the value inside of that variable will always be a pointer to some object in memory. On the other hand, in C#, another way to define a type is to define a struct, struct. Let me create a struct called point. So I just want to give you a warning as I give you this description that in writing code for day-to-day business applications, you will typically 99% of the time be creating a class definition. Therefore, you'll be creating reference types. A struct is something that we will write that is more of a special type. It needs to behave like a value type. It's typically very small, just like an integer and a floating point number and a date time. They all require small amounts of memory. And because structs are small and behave differently, they can be a lot more efficient than reference types for certain scenarios. But you have to understand those advanced scenarios to know when is it okay to write a struct type. Writing a struct is very much like writing a class in the sense that I can give a struct fields, I can give a struct methods, but there are some other special rules for structs that I'm not going to cover in this course because, again, in day-to-day business programming, you just are not creating types that are structs. But there are types in the .NET framework that are struct-based, and therefore they are value types. And then the question is, if I'm using something from the .NET framework, how can I tell if it's going to be a reference type or a value type? I need to understand the difference because when I'm invoking a method and I'm passing along a parameter that is a reference type, I can make changes to fields inside of that object if I'm working with a reference type. So I just want to show you how you can tell, how you can guarantee that you're working with a reference type or a value type. If you go up to any type inside of Visual Studio or Visual Studio Code and place your cursor on that type identifier, so in this case I'm going to select int, but this would also work if I place my cursor on book or float or double. When you place your cursor on that type and you press F12, you can go to what's known as a metadata view of that particular type. This metadata is a recreation of what that type definition would look like if you were to look at the actual source code for that type. So you can almost think of it as reverse engineering a particular type, but you're not going to find things like complete method definitions inside. But what you are going to find that is important for this discussion is you're going to see if an int is defined using a class or a struct. And in this case, I can see int is a struct and therefore it's a value type. Now you might notice that the name of this struct is int32. And that's because in the C# language, there are some special keywords for some of these built-in value type primitives. So things like integers and floating point numbers, they all have aliases in the C# language that are these lowercase identifiers. So yes, an int, if we were to go back and look at that, is really the struct int32. And those two identifiers are really interchangeable. So I could also say that this method setInt takes a parameter of type int32. That's the same as using the keyword int. Another good example of this is the double type that we've been using for floating point numbers. If I place my cursor there and press F12, then I can see I'm really working with a struct that has the name double, where the D is uppercase. So I can use D with an uppercase or lowercase d. I can use either of those to declare a variable or a field of type double. Here's another example. In C# I can use the keyword bool, all lowercase. If I press F12 to look at the definition for bool, I can see it is another struct. So a Boolean value is also a value type. And bool, B-O-O-L, is just the C# keyword shortcut for the .NET type Boolean with an uppercase B. Now, not all value types have a shortcut. So another value type in the .NET framework is datetime. If I want to keep track of the date when something occurred, I can use a datetime variable or a datetime field to keep track of that value. And if I press F12, I can look and see that datetime is a struct, therefore it's a value type. And I can use this F12 trick whenever I want to look at the metadata for any type, even stuff that I've written or stuff that's in a NuGet package. So if I come down to the identifier book and press F12, that's actually going to take me to book.cs, but I can see that book, that type is built as a class, therefore book must be a reference type. Now there is one special case type in .NET. It's a special case because it is defined one way, but it behaves another way, and that special type is string. Let me declare a variable string, set it equal to an empty string, and I just do that because really I just want to press F12 to go to the definition for string, or at least the metadata view, and you can see that string, which in .NET is technically uppercase S string, is a class. Therefore, anytime I'm working with a string in C#, string is always, always, always a reference type. Don't let anyone tell you anything different. However, string often behaves like a value type. So even though string is a reference type, quite often it behaves like a value type. What do I mean by that? Let me write some tests to demonstrate. So what I want to do is write a test to understand how strings behave, because this is something that trips a lot of people up, at least trips people up when they're starting with .NET. Let's create a new public void method called strings behave like value types. The thing about value types is that value types are really immutable. If I have the number 3 is an integer, therefore it's a value type. I cannot really change that value. So how can I reassign the meaning of the integer value 3? I cannot. If I have a variable defined as an integer, well then I can change a variable. I can place the value 3 into the variable, and then I can overwrite the variable with a new value 12, but that's not changing a specific value like 3. That's just changing the value that's in the variable from a 3 to a 12. And the reason I want to say that strings behave like value types is because in .NET, strings are what we call immutable. I cannot change a string once I've created a string. So here's an example. Let's declare a variable typed as string. So we know that that variable is going to contain a value which is a reference. So it's a pointer to some string that is allocated in memory. And I'm going to invoke a method called makeUpperCase, where I pass in a string and I expect that method to make my string uppercase, so make it all uppercase letters. I'm going to use control period to generate that method. So down here, let's say that we pass in something that I will name parameter. It's of type string. And it turns out it's very easy to make a string uppercase. There is a method called toUpper that I can invoke. There's also toLower and a couple other options, but I want to make this toUpper, which I saw in the description makes an uppercase string. And now I want to assert that my name is equal to an expected value of Scott. That's what I believe the method should do, at least. Because why is this any different than, let's say, passing along a book to some method that sets a name? So I pass book 1 to the method setName, and it can change the name of the book. So down here, all I want to do is pass a parameter of type string to a method to make that string uppercase. Why wouldn't they work the same? I mean, they are both reference types, right? But I will find that this test fails. So if I come out to the command line and run .NET test, it will take a second, and I should see that I did expect an uppercase Scott, but the actual result I got back was still Scott with only an initial uppercase S. And that's because this method toUpper does not change the string that you invoke the method on. Notice the description there says, returns a copy of this string converted to uppercase. But the key part there is it returns a copy. So there's many methods available on a string object. There's toUpper and toLower and all sorts of things that you can do to a string, but none of those methods will ever change the underlying string. They will all return a new string that you then have to either return or save into a variable. So if I make this method return parameter.toUpper, now at least I can return the new string that I've made. Of course, I will have to change the return type here to be of type string. And now I would also have to say that name equals make uppercase, and I expect that method to return to me the string that is now uppercase. And just to make that clear, let me create another variable upper, because my original name variable should always be Scott. That string will never change no matter how many times I invoke toUpper or toLower on it. But this new variable will point to my new string that is all uppercase. So if I save the file, come out and run .NET test, we should see in a second some green text. Yes, the test run is successful. And now we know that, yes, strings are reference types. So when I invoke make uppercase, I'm passing my name variable by value, but the value inside of that variable is a reference. So I have a pointer to a string. But even though I have a pointer to a string, there's no way I can actually modify the underlying string because strings are immutable. Now, when we talk about memory and we talk about instantiating objects, anyone who's new to .NET might have a question. And that question is, if I can construct objects and bring them to life and instantiate classes, then am I ever responsible for cleaning those objects up? Do I ever have to tell the .NET runtime when I'm finished using an object and tell the runtime to delete that object or free up the memory? And the answer is no. One of the services that the .NET runtime provides is a garbage collector. So the .NET runtime can keep track of all the objects that you have allocated and created, and it also keeps track of and knows about all the variables you've created and all the fields that you have inside of objects that point to other objects that are in memory. And the .NET runtime knows when there's an object in memory, it knows when there's no variables and no fields that are pointing to or using that object. And it knows when that happens, when nothing is using that object, it can run a garbage collection and clean up and deallocate that object. That frees up memory so your program doesn't exhaust memory. Yes, it is possible to exhaust memory and use up all available memory if you just keep allocating things and keeping references to things that are in memory. But the typical application will instantiate an object, use it for a little bit, and then it goes away because our variable just no longer references that object, or our variable goes out of scope. So for example, book 1 and book 2, they're both referencing the same object, but at the end of this method, there's nothing left that will reference the object created by getBook and assigned into this book 1 and book 2 variable. By the end of this method, the garbage collector and the .NET runtime can detect that there's nothing referring to that object. It can clean the object up, it can collect garbage, and it can make memory available for other tasks that are in this project. In this module, we learned a few different things. We learned there's two categories of types in .NET. There's reference types, defined by classes, and there's value types, defined by structs. We also learned when we pass parameters to methods, we always pass those parameters by value. We always pass those parameters by value. And perhaps most importantly, we learned that we can use unit tests to explore and understand how C# behaves and how .NET behaves.